So guys, welcome to our channel once again. In today's video we have here these 6 questions to answer on the topic electromagnetic field. So this video will be about the Faraday's law. So in short, stay till the end of this video. Let's go ahead and start with the first question. Here it says the direction of induced current in a straight wire placed in a magnetic field is determined by using A. Faraday's law, B. Lenz's law, C. Fleming's right-hand rule, and D. Maxwell's screw rule. So guys, the answer to this question is option C here. That's the Fleming's right-hand rule. So that's it for this question. Let's go ahead and consider the next question. So that's question number 2 here. It says the diagram above illustrates a bar magnet near a coil connected to a galvanometer. When the magnet is rapidly moved towards the coil, an EMF is induced in the coil. The galvanometer needle deflects. The magnet is attracted. So it says here, which of the statements above is correct? We have A, I and I, B, I and I, C, I and I only, D, I and I only. So guys, the answer to this question is I and I only. So that's it. An EMF is induced in the coil and then the galvanometer needle deflects. So that's it for this question, guys. Let's go ahead and consider the next question. So that's question number 3 here. It says a magnet is being inserted into a coil of wire. On which of the following factors does the induced EMF in the coil depend on? We have I, numbers of turns in the circuit, I, strength of the magnet, I, speed with which the magnet is inserted into the coil. So we have option A, I and I. Option B, I only. Option C, I only. Option D, I only. So guys, the answer to this question is option A here. I and I only. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 4 here. It says the process of producing electric current by a charging magnetic field is referred to as A. Electromagnetic induction, B. Magnet induction, C. Electrostatic induction, D. Flux linkage. So guys, the answer to this question is option A here, which is electromagnetic induction. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 5 here. It says which of the following action will not lead to an increase in the induced EMF in a coil of wire rotating between the poles of a magnet, increasing the A, gap between the poles of the magnet, B, strength of the magnet, C, speed of rotation of the coil, D, number of turns in the coil. So guys, the only option here that will not lead to an increase in the induced EMF in a coil of wire that is rotating between the poles of a magnet is option A, that's increasing the gap between the poles of the magnet. So that's it for this question, and option A is the answer to this question. So let's go ahead and consider the next and last question, guys. So that's question number 6 here. It says a transformer is required to supply 12 volts root mean square to operate a tow train set from a 240 volts root mean square. If the number of turns in the secondary coil is 100, calculate the number of turns required in the primary coil. So guys, this is very simple. In order to calculate the number of turns we have in the primary coil, we're just simply going to do the voltage E in the secondary coil over the voltage E for the primary coil is equal to the number of turns N for the secondary coil over the number of turns N for the primary coil. So when we do this, we are going to plug in the values for each of these. So starting with the voltage E for the secondary coil, that's 240 volts, over that of the primary coil, which is 12 volts. Then this is equal to the number of turns of the secondary coil, which is 100, over that of the primary coil, which is not given. So if we make X the subject of this equation, we are going to have 12 times 100 over 240 volts. So this will give us 5. And that's it for this question. Option B is the answer to this question. So that's it for this, guys. So this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.